Okay, let's look at some examples from the 1.7 homework. So first we're going to start with number 6. And if we look at this, why does this require chain rule? Well, because we have a function inside of a square root function. That square root function is gonna be my outside function and then I have this function inside of it, right? I can rewrite this as 3 plus x over 8 minus x all raised to the 1/2. Right, and there I can see a little bit more clearly how I have an inside function and an outside function, which means I'm going to be using chain rule. My outside function is, of course, just this u to the 1/2, and my inside function, if I think about what u is this 3 plus x over 8 minus x. So there's my inside function and my outside function. So what does chain rule tell me to do? Well, chain rule tells me to take the derivative of the outside function. So that's just this u to the 1/2. That just requires power rule. And I get 1/2 times, keep that inside function the same. And then using the power rule, I subtract 1 from the exponent. So I get 1/2 times my inside function raised to the negative 1/2 power. But then, according to the chain rule, right, I need to take the derivative of u, of that inside function. I need the derivative of the inside function. But what is that derivative going to require? U is a rational function. It's got a function on top of another function, which means to take that derivative, I need quotient rule. So my numerator function is this 3 plus x, and my denominator function is this 8 minus x. To use quotient rule, I'm going to need the derivatives of both of these. So n prime is just 1, and the derivative of the denominator is just negative 1. So now, using quotient rule, I can put this together. So I'm going to do my denominator function multiplied by the derivative of my numerator, which is just positive 1, minus my numerator multiplied by the derivative of my denominator, which is negative 1, all over my denominator squared. So that's me using the quotient rule to evaluate the derivative of that inside function. So therefore, when I come back up here and complete my derivative, that's what I'm going to put in for the derivative of my inside function. So this now becomes 8 minus x times 1 is just 1 minus 3 plus x times negative 1 over 8 minus x squared. So let's make sure we have everything. Here's this piece right here represents the derivative of the outside function with the inside function plugged in, and then this piece over here represents that derivative of the inside function. And therefore, I've completed chain rule. Another way I can think about it is I've got my derivative of my outside function with my inside function plugged in, multiplied by the derivative of the inside function, right? That's another way that we've looked at chain rule. Now, of course, there is a lot of simplifying that I can do here, but with Pearson, you don't have to. You can plug it in just like this, and it'll give you credit. And so it's up to you whether you want to practice simplifying. It's always a good idea to practice simplifying, but you're also just welcome to plug it in like this. Okay, let's look at the very next problem. So this is number 7 from the homework. We've got this function, 12 times 2x plus 2 all raised to the 2/3 power, and then 2x minus 2 raised to the 5/4 power. So hopefully as you're looking at this, you can see how, hey, this is going to require chain rule. I have a function inside of an outside function. But it actually happens in 2 different places. So this is another example that it's a combination of 2 of the different derivative properties that we've already learned. So if I were to back up here, what else am I working with here? Well, I'm working with 2 functions that are being multiplied together, which means I'm going to need to use product rule. I'm going to classify my 2 different functions, g of x and h of x. And a question that comes up here is, what do we do with this 12? Well, there's a couple things I can do. I can go ahead and use the constant multiple property to say, okay, that 12 isn't going to affect my derivative, so I'm just going to leave it there. I'm going to ignore it for now, and then when I'm done with everything, I'll multiply everything by 12. So that's one way I could do it. Or I could go ahead and just include the 12 with one of these functions. So that's what I'll do for this example. I'm just going to include the 12 with my first function, and then my second function is just going to be 2x minus 2 raised to the 5/4. In order to use product rule, I need the derivatives of both of these functions. So I'm going to take this derivative. So when I take the derivative, remember my constant multiple property tells me that I'm going to leave the 12 and just focus on this power function. And this derivative, this is where I'm going to use chain rule. When I focus on each of these individual derivatives, each of these derivatives require the chain rule because I have a function inside of another function. So chain rule tells me to take the derivative of the outside function, which is just this 2/3 piece. That's my outside function. And so the derivative of that just requires the product or the power rule. So I get 12 times my power. I'm going to keep the inside function the same and then subtract 1 from the exponent. So I get negative 1/3. Well, that's just the derivative of the outside function. Everybody, hopefully we see that, right? So that's me taking the derivative of the outside function. The 12 was there because of that constant multiple. And so now I need the derivative of the inside function. Well, what's the derivative of 2x plus 2? It's just 2. It's a linear function, so your derivative is just the slope. And now I can simplify that if I want to. Remember, you don't have to simplify these in order to get them correct on Pearson, but simplifying is always a good thing to practice. 12 divided by 3 is 4. 4 times 2 times 2 gives me 16 times 2x plus 2 raised to the negative 1/3. Okay, well now let's look at h of x. H of x is going to look very, very similar because it's the same type of function. We have a linear function inside of a power function. And so I'll use the chain rule like I did earlier. I'm going to bring down that power, multiply it by the power, keep that inside function the same, and then subtract 1 from the power. 5/4 minus 1 gives me 1/4. Then what do I have to do? Remember, then you have to multiply by the derivative of the inside function. This piece is only half of your derivative, because then you have to multiply by the derivative of the inside function. So derivative of 2x minus 2 is once again just 2. So what do I get when I simplify that? I get 5/2 times 2x minus 2 to the 1/4. So now I have the derivatives of each piece. Now what do? Well, now I put it all together using the product rule. So now I can come over here and say, okay, f prime of x is equal to, and I'm going to use the product rule. So I'll go ahead and start by doing g of x. So 12 times 2x plus 2 to the 2/3. What do I multiply g of x by? By the derivative of h. So multiplied by 5/2 times 2x minus 2 raised to the 1/4. It's half, right? So then second half I'm going to add, and then I'm going to do the reverse. So then I'm going to have the derivative of my g function, so 16 times 2x plus 2 raised to the negative 1/3, multiplied by my h function, 2x minus 2 raised to the 5/4. And now, once again, you can put it in like this, and it'll mark it as correct. You don't have to simplify unless it specifically tells you to with these Pearson problems. But simplifying is always a good habit to get into. 12 times 5/2 is 30. So I get 30 times 2x plus 2 raised to the 2/3 times 2x minus 2 raised to the 1/4. And then when I multiply this one stays pretty much exactly the same. And there we go. There's my derivative. Okay, let me know if you have any other questions from this homework, and I'll see you in the next video.